I'm really privileged to both be here and have this panel, which I'll introduce in a moment. Actually, I'll introduce you now. So what we have here is three entrepreneurs. So me, and I'm the CEO of 3D Robotics, Helen Greiner, who is the CEO of CyPhyWorks. I want to understand whether you got a cease and desist from LucasArts after the DroidWorks initial name.
I'd rather not talk about that.
Rather not talk about that. Zack Schildhorn, a venture capitalist who will tell you a lot about the sort of investment opportunities. Jonathan Downey, who's the CEO of Airware, another venture-backed company in the space. And Matthew Pobloske, who from British Aerospace, BAE Systems, who is going to represent the aerospace industry, the disrupting the counterpoint to the entrepreneurship angle. My job as partly an entrepreneur on the panel, but also as the moderator, is to both frame the opportunity in the moment and also to get a little bit of a conversation going on the panel and then bring in your questions. We're going to speak on the panel till about 8 o'clock. Maybe 8:05, and then we'll take your questions on till 8:25. There's a phone number that you must text. Can we bring that number back up? Right there, 650-308-8522. During the conversation, please text your questions to that. They'll be brought to me on an iPad, and I will try to run interference on that. So why are we here? Why now? Why here? Let me bring up my slides first, and I'll give you a kind of a sense of why I think this is an extraordinary moment in this particular space. As Hiroshi said, this is, the answer, the basic answer is why we're here is this, as far as I'm concerned, the smartphone. The phone in your pocket right now I'm saying there's a slight amount of hyperbole, but not too much. The phone in your pocket can fly a 747 with the right cable and the right software and permission. Which you're not going to get. But basically, there is the most extraordinary thing happening in the smartphone industry, that the race to put supercomputers in our pockets with the economies of scale and Apple and Android have created a Moore's Law pace like we've never seen before. What you have in here, in your own pocket, are MEMS sensors, microelectronic mechanical machine sensors, gyroscopes, accelerometers, magnetometers, GPS, cameras, wireless, incredible advances in the processors, the ARM core processors you have in there, to say nothing of batteries and memory and the wireless modules. It's amazing, and we now have these being made in the billions. Thanks to the Apples and the Androids of the world, we can now buy these components for pennies, dollars, if you will. You can buy them at Radio Shack. The components inside these phones are creating a revolution in robotics broadly. The components have incredible application outside of the smartphones. And so, when Hiroshi describes this as the peace dividend of the smartphone wars, what we really mean is this stuff, 10 years ago, it was unobtainium. These sensors, these processors, this GPS, these cameras were impossible to get. They were military industrial technologies. They were export controlled. They were incredibly expensive, and now you can buy them at Radio Shack. That's why we're here. We're having one of those classic Silicon Valley moments, one of those homebrew computing club moments. The reason I'm here is that 5 years ago, I have 5 children, and 5 years ago, I was trying to get them interested in science and technology, and this is sort of what I do. I started a site called Geek Dad to do this. I'm going to jump to the end of the story and say I failed. I consistently failed. My children are not interested in science and technology. But 5 years ago, I hadn't yet given up. And I brought home a Lego Mindstorms kit. Does any of you have ever experienced Lego Mindstorms? Yeah, exactly. Lego Mindstorms, cool stuff, right? So this is the NXT, and I put it together. And I thought this is going to be an awesome morning for my children. We're going to build a robot, right? And we're going to program it. And we spent all morning, we built a tribot, the 3-wheeled bot, and we programmed it. And when you program it correctly, it will approach a wall, detect the wall, and then back up. And the kids are like, you've got to be kidding me. Right, I've seen Transformers. Where are the lasers? Right, that sucks. And then I was given a model airplane, a radio control airplane, which we took to the park, and I flew into a tree. And it wasn't just the embarrassing flying into the tree, it was the fact that I climbed to the tree to retrieve it that was ultimately mortifying, and I had to bribe them with ice cream. And it was just a kind of a terrible experience. It's really hard to impress kids. So I thought, what would impress the kids? And I thought, what if the Lego could fly the plane? It would sure do a better job than me. So there it is, the world's first Lego autopilot. My children and I built that 5 years ago on a dining room table. One of those little boxes on the top is a 3-axis magnetometer, one of them is 3-axis gyroscope, one of them is 3-axis accelerometer. And it is not the world's best drone. By the way, this is what it looks like when you put it in a plane, like there. That is the world's first Lego unmanned aerial vehicle. It is in the Lego Museum in Billund, Denmark right now, I'll have you know. It is not a great unmanned aerial vehicle. It is lucky to still be in one piece. However, the fact that my children and I could build a drone around our dining room table, when I actually had to Google, like, Kalman filter, I had never heard of any of this stuff, but the fact that me and my children could build one of these around the dining room table, despite the fact that they lost interest, I thought, there's something going on here. Something's happening. This should not be possible. By the way, I later talked to some US government officials who said, well, technically what you did is you created an export-controlled technology, and you weaponized Lego. And they then sent me this form that said that after we exported this by putting it on the internet, they said, well, have you confirmed that anybody who uses that outside the United States has it under 24-hour closed-circuit television surveillance and has a login manual? I'm like, we are talking about Lego, right? And they're like, technically, it's a cruise missile controller. Anyway, so something weird is going on. And what's weird that's going on is that these technologies that used to be military are in your pocket. That those chips got out there, and they ended up in plastic, in Lego, and in Radio Shack, and in your phone, and now everywhere else. So I decided, my children lost interest, I decided to go down the rabbit hole. What I did is I created a website called DIY Drones, largely to be stupid in public. I'm a big fan about being stupid in public. When you're stupid in public, what happens is a couple things happen. A lot of smart people come and help you get less stupid, and that's nice. And the other is that it turns out other people were feeling a little stupid as well, and this is a place for them to be stupid too. So today we're, I think, the biggest robotics community in the world. And the fact that you can put the letters DIY in front of drones is kind of why we're here. And this was designed to kind of be a homebrew drone club, like the homebrew computing club. And that what Jobs and Wozniak did when they discovered there were these chips that you could buy. What was it, the 8088? Anybody know? What was the 8088, yeah. The fact you could buy this chip that could be a computer enabled the personal computer, and now there's these chips that you can buy that can make a drone. And so anyway, that's where we started. And these are just this is just one of our autopilots. By the way, this is what a bunch of amateurs on the internet can build. This is an autopilot. Right here, you put it in any vehicle and it becomes a drone. Helicopter, multicopter, airplane, car, boat. We haven't tried submarine yet. We're working on submarine. But the fact that that a community of volunteers can build drones is kind of revolutionary. And the reason we can do it is, again, these are just the comparison. That's just one of our autopilots versus the iPhone, just to show you the commonality in the chips. That's what it looks like. That's what a $179 autopilot looks like. By the way, that flying wing you saw flying overhead, that was controlled by this on a mission, on basically a lawnmower pattern. And today, this is sort of where we are right now. This is what this community built. This is an ARM-based processor. It's got all those chips right there are just right out of your phone. That's our Cortex M4 processor. That's what regular people can do today, and that's amazing stuff. This is military-grade technology, and it's available, for free. It's all open source. If you want us to buy it and make it for you, we'll charge you. But if you want to make it yourself, it's there. It's open source. So, the point is that we've had this moment. We're having this homebrew, computing club moment where suddenly we can offer military-grade technology for toy prices. And this is incredibly disruptive. It's disruptive on a policy basis. It's disruptive on a commercial basis. It's disruptive on a nation-state basis. It's disruptive on a security basis. It's disruptive on a privacy basis. It is disruptive. It is a classic Silicon Valley moment. And look at these words that we can introduce. I mean, in the same way that there was a computer before the Apple, it was called the mainframe, and then we introduced words like personal and desktop, and that was disruptive. Now we can add words like personal to drone. We can add words like classroom to drone. We can add words like disposable to drone. And I can tell you that the military-industrial complex, the aerospace industry, was not going to bring you disposable drones, but maybe the grassroots will, and that's a classic disruption. So these are the kind of drones you saw. Some of them outside, but these are this is the kind of things that are possible. These are multicopters and planes, and those icons right there. That's an example of what happens when you download some free software and you say, what kind of drone would you like? Would you like a car drone? Would you like a plane drone? Would you like a traditional helicopter drone with a gas engine that can stay in the air for an hour? Or would you like an electric-powered multicopter? Would you like 4 or 6 or 8 propellers? Or do you want them in different configuration to give room for the props? That's now possible by just clicking a button. And that used to be really hard, and now it's free and easy. And what a drone is it's an aircraft capable of autonomy. You don't have to fly it anymore. It's a plane with a brain. And so this is what piloting a drone looks like. You don't pilot it at all. You give it a mission plan. And you give it waypoints. You click on a map, and those waypoints have functions. You can sort of take off or land or loiter or follow an object or look at a region of interest or change altitude or control cameras, all that stuff. That's what it means. And at this point, we're no longer pilots. At this point, we're now trying to figure out, what do you want to do? What mission do you want to accomplish? What job do you want done? And let the drone do the work. Robots do jobs that are dull, dirty, and dangerous, with the vast majority of those jobs being dull. And that's what drones are great at. Let the drone do the work. Humans should not be operating heavy machinery, drunk or not. So a little sort of fun example of just sort of things that you don't think of. So right now, drones have a terrible word, and you guys are probably going to fight me on the use of the word drone. But we use the word drone because that's what the public perception has. But it resonates. But they think of it as the military. But what if a drone, well, let me ask the question: how many people in this room have crashed a model airplane? Exactly. I'm going to put up 2 hands. What if you could put this little box in your model airplane, and it wouldn't crash anymore? That's called geofencing. And what you do is you just sort of define a box, and you sort of say this box is a X and a Y, and it has a floor and a ceiling. And you say, don't leave that box. If you leave that box, if I accidentally slam the stick forward and it goes spiraling into a horrible death dive, the moment it hits the bottom of the box at 100 meters or whatever you set it at, it takes control away from you, and it puts it back into that center point. And this is right there. That's a data log of us trying to break the box. And what happens when it hits the board of the box? It takes command away from you and brings it back to the loiter point. And that's a safety measure. That's a training measure. That's a way to make flying fun again. Because when things go wrong, the computer takes over. And that's a drone. But you don't think of it as a drone. You think of it as a training aid. We think radio control is a terrible interface. We like phones. We like tablets. Does anybody here have a Parrot AR drone? So it uses a tablet and phone, but you got to tilt it, and it's really hard to fly. What if you didn't have to do that? What if you just tap on the map and say, I'd like it to go there, and I'd like it to do this? So that's kind of what we do. This is an iPad interface. But that's kind of, again, the sort of thing you do to mainstream this technology. You just tap on the map, and it goes there, and it does that. And this is kind of the fun thing. If you happen to be into sports, I know, Helen, you were just kite skiing.
Snowboarding.
Kite snowboarding. Even cooler than kite skiing is kite snowboarding. So do you have any video?
There was a drone taking a video from Skycatch guys were there. Is the Skycatch guy in the audience? No?
How awesome is that, right? She was kite snowboarding, and a drone was taking the video. So I think everybody should have access to that. So we think that there should be this box you wear like this, and when you want awesome airborne video in high def, you should just push the button, and the drone should come up and follow you around 30 feet back, and just follow you around as you do your thing. And when the battery runs low, it should land on the shore and recharge or whatever. So that's possible. That's like science fiction, right? Until now, and now it's easy. Now it's like $500. Anyway, so we do that kind of stuff. We think the commercial consumer, the kind of the GoPro generation wants their GoPros to have wings, and why shouldn't they? These are the droids you were looking for. So I want to show you a little video. Oh, let's go back. Can we show this video? This is from the movie Looper. Anyone see the movie Looper? It's a great movie, by the way. Remember this scene? Okay, she's on the farm. She just touched this bit of farm equipment. And this bit of farm equipment then takes off and does what it does. It's a robot crop sprayer. That's science fiction, right? That's happening right now. This, by the way, is the AUVSI prediction of commercial drone use in the United States, and it's just all agriculture. Those guys, that flying wing you saw flying over there, from the airframe guys, have they entered the room, airframe team here? Yay, airframe team, okay. So they're out, these are Stanford engineers, they graduated, and they went to Davis, California to walk the fields and to understand what agriculture UAVs actually mean. And when you think of UAVs in the commercial sector, you probably think of scary stuff, military, police, et cetera. But think about them like that Looper video as farm equipment. The highest economic benefit with the lowest regulatory barriers. Farmers know very little about their crops because crops get bigger and bigger with farm consolidation, and there's fewer and fewer people who want to work on them. It's a perfect place for automation. You've already seen dairy farmers become, automated. You already see, tractors driven by GPS. Why shouldn't they have aerial images of their crops on a daily basis and know if they're using too much chemicals, if too much water, if they have a disease outbreak that they should know about, if they should harvest now and not later? That's not possible right now because they don't get that top-down imagery. The Google satellites go by once a year. What if you get a daily crop survey powered by a drone, and maybe spray by drone as well? So today we think of drones as being weapons, as being military. But what if you thought of them 5 years from now as being farm equipment? The kind of thing you just regularly see as you drive through the fields of Napa. You see drones surveying crops and spraying them. That's science. Looper says that's science fiction. I think this panel may suggest that's happening already. So with that, that's the sort of overview of where we're at. Sorry, I had one more slide I want to show you. That is what you think drones are today. It's military. It's expensive. $10 million products like Global Hawk and the Reaper and the Predator, et cetera. And my point is that the Silicon Valley perspective is to say every time you can bring the cost of a product down by an order of magnitude, the volume goes up by an order of magnitude. And the way we change the world is by democratizing technologies, is by putting them in the hands of regular people. Right now, the military world stops at the sort of tens of thousands of dollars for drones, and the civilian world starts at the $1,000 of drones. But we think drones will be under $100. We think fundamentally autopilots, the essential technology, will cost tens of dollars. They may be built into everything. They're essentially built into your phone already. And so when you look at that order of magnitude analysis, I think my lines are messed up, but you get the point. Right now we're right at that interface. All of our drones at 3D Robotics cost under $1,000, and we think they should cost under $100 in a few years. Think about what that would do. Those of you who have a Parrot AR drone, those cost $300, and there's 500,000 of them sold, but they're not really drones. They're not capable of autonomy. But what if they were? And what if they were $99 and capable of autonomy, and smarter autonomy? They just figure things out. What if your smartphone really did have wings? How would that change the world? So that's the moment we're at. And I just want to remind you that that computer right there, that original IBM PC, it didn't come from scaling down the mainframe. It came from scaling up this homebrew computing club thing. So it's easy to dismiss the homebrew computing club. It's easy to dismiss the amateurs playing with, chips they bought at Fry's. But that's what changes the world. That's what our factory looks like today. 5 years after me playing with Lego, that's what we look like today. That's what regular people can do. My co-founder, 19-year-old high school graduate from Tijuana. The whole team's 25. That's what 25-year-olds can do. in 5 years, well, 3 years, today, because we're drafting on the revolutionary technological advances of the smartphone era. So, good stuff. Helen, I think you have the next presentation.
Okay. Well, I think I'm talking now because I'm the featured startup, and thank you for the invitation to speak today. It's actually been a long time since I've spoken to the MIT Enterprise Forum, so I'm excited. And I'm going to talk today about a new class of UAVs. Sorry, I'm using UAVs, not drones. It's what I'm used to, called microfilament-enabled UAVs. Just a little about the company. I stood up CyPhyWorks to be an innovation works in robotics in general, and our first two products are these small UAVs with unlimited duration. We've also done a lot of work in GPS-denied controls. We have a world-class engineering team, and I know everyone said that, but I scored some of the top roboticists for my robot, a guy who invented inkjet printing when he was at HP, and some of the top UAV inventors coming out of the DARPA small UAV programs. Got experienced robotic executives, like Matt England, who he deployed some of my ground robots for my robots over in the caves in Afghanistan as a lieutenant colonel. And he also deployed the first Ravens and Wasps over in Afghanistan and Iraq. And he got like $2.7 billion worth of military products to the soldiers in a rapid way during the recent conflicts. We raised $2.7 million in a Series A round, and we've augmented that with government research contracts. So UAVs already existed. When I was doing ground robots, I would go to the AUVSI show, and that was our big industry group, and there were so many UAV vendors. I always said to myself at iRobot, we're never going to do UAVs because it's just so damn crowded. But then I wanted to do something new. I wanted to learn something different, and so I started talking to people using the UAVs about what their problems were. And I've got 3 really big answers, and the very first one was they have a pretty short time of flight. If you have something about this big, if it's a fixed wing, it can fly for maybe an hour, maybe 2. But then when you go to a rotorcraft, it takes more energy, and if you have something this big, maybe it flies for 45 minutes, half an hour. But when you go smaller, when you want it to get into a building or something, it really has like a 15, 20-minute time of flight, and then the user won't want to put payloads on it, so it kind of scales really, really badly. Poor communications, they work really well line of sight, but if you're in an urban canyon or if you want to go indoors, you have the same problems as we had with the ground robots in getting the communications link to work. And then the vulnerabilities, not as much an issue in commercial, in consumer applications, but when you're talking about military or civil applications, if you're transmitting wireless, you can be detected, giving away your position. You can be jammed, and you don't have to have a sophisticated military jammer to jam a signal. You just have to put a lot of noise in the environment, so you can do it with very, very, very cheaply if you're malicious. And then they can be spoofed. We have red teams working in the military, and they've taken control of all the military, the small robots, and then they can operate them and see the video from them. So that could be kind of bad, even if you're in a law enforcement situation and someone can take control of your plane. And hackers would do it, like some of you guys, just for the fun of it. So we have a unique solution to this problem, and we call it a microfilament, which is a physical link between the UAV and the ground. And this physical link, we do power, Ethernet communications, and HD video. And the trick is it's really, really long and really, really light because you don't have a lot of payload capacity. And this gives you unlimited time on station. So you send the UAV up, and it can just stay there. And it can't be jam spoofed or intercepted. And you can see the size of it is quite small. So this is one UAV we've built with this technology. It basically send it to a preset altitude, it parks itself, and it stays there until you bring it down. And when it's up there, it can do persistent reconnaissance. It could act as a communications relay, so the soldiers can talk over their communications equipment for further distances. And it also The customers can add whatever kind of interesting payload that they like, and it's usually communications equipment to go longer and longer distances. And it's easy to use. You set an altitude, you push a button, and the robot takes care of the launching. And when you're ready to come down, you just press a land button, and the robot takes care of everything. No piloting skills are required. A short video of it functioning. Now, this is a quad rotor, the park, and you can't really see it, but it did have a microfilament attached to it, and it still does, and it's being powered from the ground. This is just showing it's got a fairly large HD Sony camera on it. It's got a pan-tilt gimbal camera, so you can see video in real time coming back from it. It's not quite stabilized entirely well yet, but I like to say that's a solved problem. We just haven't solved it yet because we've been concentrating on getting the robot to work. They saw some people on the road, and then they wanted to see out a kilometer for these other set of people. So this was an Army assessment, and we got really, really positive feedback on it because it really scratched an itch that they have. They don't want to keep launching a UAV, bringing it down, and then launching again. They just want constant eyes in the sky. And then the next one we're working on is what we call EASE, Extreme Access System for Entry, and it goes into buildings. It's really hard when you send a robot into a building. The ground robots, you send them in a few rooms or into the basement, and you no longer can see what the robot's seeing. And then you end up sending a soldier in to get it back. And having a soldier get injured because they're saving a robot, or a police officer go into a dangerous situation to save a robot, is really not a good idea. So this microfilament eliminates RF dropout. It's spooling from the vehicle, so it never gets tangled. It never gets any tension on it. So you can go in through the second-story window and come down, through the entire building. And it's not limited by onboard batteries at the time of flight. Here's a short video of it. This is a little bit smoke and mirrors here. It's not doing the full thing. It doesn't have the camera in front. It's not transmitting video right now, but it is being powered from the microfilament. And you see, when one of these vehicles is outdoors, it uses the GPS to bound the drift on the IMUs through that Kalman filter that Chris was talking about. But when you're indoors, you can't do that. This is using a vision system to stabilize the vehicle. And you can see it's doing a little pirouette to see all around the area. And now it's going to go back outdoors. And what we'd like to do with it is show, well, stepping back, I built a lot of ground robots. I delivered 6,000 of them to the military. They've been credited with saving the lives of hundreds of people, hundreds of soldiers doing IED defeat. But they can't get everywhere. If someone puts a fence up, or if there's a ditch, or if there's staircases that are a little bit bigger than the robot can get over, it stopped. We like to say the problem with ground robots is the ground. So with this, we can really start to think about getting anywhere, and that's exciting to me as a roboticist. Just briefly, the markets that we're attacking. Many of you in this room already know this, but the FAA does restrict commercial operation of drones in the United States today. So we started out looking at the military market with this technology. I've already talked about reconnaissance, surveillance, communications relay, building clearance. There's also an application to be a mobile sensor mast. So if you have a vehicle, you can have this up above it, and it can do a bubble of awareness around you. And I think there's just a lot of applications for that, including things like Google Street View. Then the next market we'll attack is the civil market. That's partially open today. You can get what they call a COA, a certificate of authorization to perform missions for police forces and firefighters and rescue personnel. But we think the markets for the long duration will be anytime you want to get sensors up high and keep taking a look around. And then there's so many applications in the commercial market. I'm only talking about the ones for long duration, small UAVs. So I don't see that much of a market for us with agriculture. But bridge inspection, there's 600,000 bridges in the country, and they all get inspected by mandate every 2 years. It's 90% a visual operation. Anytime you have a building and you want to rope people in and send it up, there's the Washington Monument, or even traffic monitoring. You want to look at a large distance and not just a point view of where traffic's running, but you want to look at a few kilometers. You can do it from a system like this. So just a quick summary. We think that the microfilament-enabled air vehicles, they're persistent and resilient platforms. You just send them up, leave them there, and they have applications in military, civil, and commercial use. And with that, I think we're going to start the panel.
Exactly. Thank you. So we have a mix of entrepreneurs, a venture capitalist, and an executive in a large aerospace company. Zack, let me start with you, because I think you probably have an overview of a lot of this. You get a lot of pitches. You're interested in this space. What we're really looking at here is the new opportunities, the commercial opportunities, civil, military opportunities, and the opportunities for disruption. What interests you most?
It's a great question. I mean, we started exploring this space actively about 2 years ago. And just for a quick background, Lux is a venture firm. We focus on all early stage real technology companies. So no Angry Birds, virtual pigs, web analytics. It's all matter that matters, I like to say. And we started looking at this space really with a military purview initially, because we saw what was happening in that market and found it very hard to ignore. I mean, you saw tens of $100 million Joint Strike Fighters being replaced with hundreds of much less expensive drones. And it was an area where there seemed to be no barrier for that disruption to continue. And you're seeing that today as well. And I think you're absolutely right in saying that the technology avalanche, this declining cost that we're seeing, is really important as a driver for this space as well. I mean, the average citizen today has capabilities in their pocket that the President of the United States could only dream of a decade ago. And that's almost unfathomable, I mean, but it's true. And I think we look at this market two ways. And one is, what are the unmet needs for these unmanned systems, right? So what can you do that nobody else can do, whether it's materials, vision, communications, propulsion, endurance, whatever it is, what can you do that nobody else can do that might be valuable to the providers in the military or commercial markets? And the second thing is, how are you leveraging these technology trends to do something that wasn't possible before? And the one point I disagree with you on is you showed a chart that had a huge red component, which was a prediction, and we all know predictions are really hard, so who knows. But it was all agriculture, and then this little thing, other, on the bottom. I would argue that you're more likely to see the inverse of that. We don't know how these systems are going to be used. And agriculture might be a very large market, and it might be a near-term market, but the question that perhaps your predecessor, Kevin Kelly, would like to say, technology is not interesting when one person has one, but when everybody has it. And as this technology continues to evolve and be in the hands of people, we are going to see applications emerge that we never imagined. And that's what we look for. And it comes it comes down a lot to the entrepreneurs and the people that are envisioning applications that weren't possible before. And some of it comes down to the technology as well.
So I completely agree that, by the way, that chart came from ABSI, and although I love it because agriculture is the best thing I can think of, I know I'm wrong. And if you asked Jobs and Wozniak what the personal computer was for in 1977, they would have said to program. And that was a sufficient answer, but was also the wrong answer. And they knew that. They knew that the only way we would get the right answer would be to put the technology in the hands of regular people, and they would figure it out. So we know we haven't. I'm going to hesitate. I don't want to use the word killer app because we're talking about drones, but we know that there is. We know that we're wrong. We know that there is some amazing application of unmanned aerial vehicles out there that none of us have thought of, and the only way we're going to find out is by putting them out there. So let me switch now to an aerospace company. Now, I know you weren't always with an aerospace company. You're recently with an aerospace company. But this has been an aerospace industry monopoly to date. What does it look like now as you sit here in Silicon Valley with a bunch of people who were playing with Lego 5 years ago, saying how they're going to eat your lunch? Does it feel like you're the IBM to the Apple?
It wasn't that many years ago. We were playing with the Legos too, and that as I said earlier, I came to this as a platform company, a small startup that did the noble thing and cashed out to the large BAE and became an employee several years ago. But that said, I mean, if you look at the opportunity as it existed back then, it was truly platform-based. You described building a platform, and that platform is the actual airframe, the aircraft, and the constituent components necessary, the autopilots, et cetera, necessary to make it fly. But at the end of the day, it's not the platform that anybody buys. It's the ability to place a sensor in situ in an environment that they weren't able to do the day before unless it was in the air. And your question earlier about the future, where we're going in the future, and in my mind, it's to divorce yourself from the thought of an airplane and forget the fact that you're looking at an airplane and look for sensors and look for devices that need to be placed or optimized, can be optimized by placing them in the air, either looking up or looking forward or looking back or looking down or just sensing what's around them, as we do with a lot of our geosciences customers, and figure out how to get that into an airborne platform. Because there's lots of platforms out there, right? There's fixed wing, rotary wing, manned, unmanned, ground-based, which in a sense is an unmanned platform as well. Depending on how high the mast is, it can be an unmanned aerial platform moving around. But and give that some thought and follow those reasons. Because I agree with you completely. There is no way to know what they will be used for in even 5 years or 3 years.
So you've talked about sensors, but then you use the verb look. Are they all cameras, or is there something else?
Yeah, that's the other thing I was thinking. Everybody, all of these presentations and a lot of what we're doing, very much so focuses on the visible aspects. I can tell you that our most successful sensors to date, and I can't get in a lot of details about some of them, but have not been visible in the visible spectrum. They have been sensors, one of which is hyperspectral, that is obviously goes from the UV to the IR. Some of that spectrum is within the visible range, but the output you get from it is not a pretty picture. But there's an incredible amount of data to be exploited within that. In fact, our largest agricultural customer is adept at using that for a variety of purposes. And the other one are RF devices and meteorological sensors. We've spent as much time in many respects flying particulate sensors for the likes of Scripps, doing geosciences and atmospheric research, as we have flying an IR camera over Afghanistan, which we do as well. So again, it's not about the visible. It's about applying and using these UAVs to gather data and put a sensor in the air. And what that UAV looks like is in many respects irrelevant as long as it stays up, as long as they need it to. It's an appropriate size, weight, and power to be able to operate it in the environment that they want to operate it in. Global Hawk is one example on the high end, or potentially an unmanned 747 flying boxes around the world is one that I think you'll see very, very soon.
Or not a 747.
Or not 747
that's
flying
a
boxes.
passenger plane. I mean, completely suboptimal for packages.
Go buy a Cessna 150 for $15,000.
Or a flying wing or something that was optimized for unmanned flight.
So I think there's, there's lots of permutations of the industry and the way it's branched out. Again, like I said, we got in the right position 15 years ago, and we're selling a platform that was disruptive. Our platform isn't disruptive anymore, right? It just simply isn't. It's a very useful platform, but it's not a disruptive platform anymore. So we need to obviously continue to expand and develop the opportunities as they exist.
Jonathan, 2 years ago, you started a company in this space. Talk a little bit about the opportunity that you identified and what your company does and what you think is the transformation.
Sure, I'm Jonathan. I'm the CEO of Airware. And what we identified in the industry was an area in between kind of the hobbyist and open source solutions available and the very kind of high-end military solutions. So we've created a development platform for small drone aircraft with an emphasis on a lot of these emerging commercial applications that we're talking about and a lot of international applications. So a lot of our first customers actually are doing these types of applications internationally today in countries like France and the Netherlands and Cameroon and India and soon to be Kenya for anti-poaching operations at a conservancy there. And by leveraging our development platform, it's similar kind of to the autopilots that DIY Drones makes, but kind of at a order of magnitude higher price point, and with kind of professionally developed API and professional support. All of our software is developed in-house, so just a little bit of a different strategy in terms of who's writing the software and kind of what it was targeted to when it was written.
So I identified agriculture as the market I was most excited about. What are you most excited about?
From a personal standpoint, I'm really excited about the anti-poaching operations that we're going to be involved in Kenya and probably South Africa as well. From a business standpoint, I think infrastructure inspections, as Helen mentioned, are also going to be very large.
So let's talk about the sort of elephant in the room, which is that all of us are in the gray area of regulation and legality. Right now, just to kind of make clear what the rules are, in the United States, commercial use of unmanned aerial vehicles require a COA, Certificate of Authorization, which is hard to get.
Except in restricted airspace.
Except for restricted airspace, which you do not live in. And if you don't have a COA, you have to fly as a non-commercially, under 400 feet, within visual line of sight, away from built-up areas, away from airports, et cetera. And yet, we're all here because we think things are going to change. There is a congressional mandate for the FAA to put in place a regulatory process for commercial use in the national airspace, which, by the way, is everything out there. But not quite clear how it's going to work. We're not clear when it's going to happen. It'll be more clear, but it won't be clear enough, et cetera. Well, let's start with you, Zack, and then Helen will come back to you. This is murky. This is super murky. I mean, anybody starting a company right here, and Jonathan, I know you feel it as much as anybody, we're all dealing with some risk. We could be, is it export control that puts us out of business? Is it a lawsuit? Is it the FAA that puts us out of business? Is it liability? I mean, any one of the above. We don't know what the rules are. Every day, somebody who's using drones to do a Hollywood film set or map a building gets a cease and desist from the FAA. And yet, at the same time, hundreds don't. So how do you invest in a world so unclear?
It's a great question. I think a lot of companies are operating under that classic paradigm of ask forgiveness, not permission. And that's likely to continue. I think it's a tricky area, and it's one where it certainly is risky to make an investment in a company that might get sued or might have a cease and desist from the FAA or might have an issue with federal regulation. But I think there's a broad industry dynamic that's happening that a lot of people maybe aren't paying attention to that I think is pointing in this industry's favor. And that's coming out of the military side, which is you've had these companies build up these huge programs that have been very successful, very profitable programs over the past decade. And as we are now pulling out of theaters of operation internationally, you have these large, traditionally defense companies that are saying, hey, wait a second, where are our next dollars, our next contracts going to come from? And they want to push into commercial applications. I mean, you have commercial customers today. I would imagine all of these companies are scrambling to find those next big markets, whether it's international, where there's certainly an opportunity, or commercial. And as you see, I mean, no offense to this industry, but it's an industry that's been very good at winning government support and approval. Those talents and those people and those resources, I think you're going to see applied in a way to try to get support to push these systems into commercial areas. And I think that dynamic, as well as the upwelling of interest from all of these upstart companies, is going to create a situation where we will see approval. We won't know how the law is going to evolve, and I think technology is almost always ahead of regulation in almost any technology industry. So I don't think that's going to change. But as an investor, I don't think that's our number one concern.
Helen, what does a filament buy you in terms of regulatory cover?
That's a unclear area, but we believe that the FAA will open up the airspace within a few, they say 2015, but we're hoping there's a groundswell of young entrepreneurs who go out and just do it, not in restricted airspace. And that'll kind of push so we encourage others to jump in and start doing it.
Take the arrows in their back.
Yeah.
Are you a kite or are you a drone?
What's that?
Are you a kite or are you a drone from a regulatory perspective?
It's a very unclear area.
So the fact that you are tethered to the ground does not automatically exempt you from UAV regulation?
Well, I think this is something that should be explained, since there are some young entrepreneurs who want to do drones, or any age entrepreneurs who want to do drones. It's not just the getting the COA. There's also the experimental license and the airworthiness certificate that you need to go through a whole process after.
So I know nothing about any of that. I've been doing it for years. Am I in gross violation?
Well, you sell to the hobbyist community. And that comes under another statute for the FAA.
Well, I guess what I'm unclear about is, you're a bird on a string, more or less. How exactly is that an FAA rule? I mean, you're tethered.
The FAA controls the airspace, and they tell me from the ground up until space.
So the fact that you've got a string on it doesn't make any difference?
Flying in that space.
But are you
apparently they don't control birds, but...
part
of the problem is none of us here believe that these rules make sense or that they're fair. When you have, I don't know how many, but tens of thousands, 500,000 AR drones flying around, and you can do that as a hobbyist. Nobody believes it creates more of a safety issue to have this flying commercially. And when you're doing something like bridge inspection or building inspection, if there's a plane nearby, it's got another problem, and it's not the small drone.
Well, there's a lot of this is kind of reductio ad absurdum, right? Mm-hmm. It's clearly technology has passed regulation, but basically, so I can put a GoPro on a long stick and look at a bridge, but I'm not an FAA issue. I can also go to the park and fly a kite, and I presume I'm not an FAA issue.
I can't really take the other side of this argument, but they tell me anything that can negotiate into the airspace, because what they're afraid of is it going out of control. Say if your autopilot doesn't work and it zips off into 2,000 feet and a plane
it's
comes.
an interesting comment, though, because as a hobbyist, as a non-commercial entity, there exists right now Futaba radios, off-the-shelf radio control devices that you can pre-program to fly your airplane. So you can push a button and allow that airplane to go fly autonomously, even though you're holding the box in your hand. And you're completely outside of the FAA guidelines as a hobbyist and a model airplane enthusiast to do that.
Well, this has been true for 40 years, that you can lose radio contact with your radio control plane and off it goes.
Had that happen.
Exactly.
So we can all agree the rules make no sense.
Your point is that it's a gray area. It's a massive gray area. Yeah, fair enough. Jonathan, let me come back to you. You're in the midst of you've just raised a round. How did you answer these questions about what will the rules be?
Well, one thing that we did was, bypass the United States a little bit and focus all of our energies international and say that, we understand that there's a lot of countries in the world that are farther along than the United States in terms of allowing commercial drones to be flown in their airspace, if not anytime, anywhere, at least under certain circumstances that don't require the complete, COA authorization. So that's where a lot of our focus is right now.
So can I ask a question on that? Yeah. What about the ITAR, the International Trafficking and Norms Regulations that restrict exporting things labeled as UAVs or autopilots?
Sure. So we've gone through the process with the U.S. government to be governed by the Department of Commerce export controls instead of the Department of State.
They
So
haven't
you get an
used, they
export
haven't used
license for
defense
each.
money. They haven't used defense dollars to develop the
Right.
product.
They typically look at three things, where you got your funding, whether you developed your product to specifically meet military requirements, like a request for a proposal, and then who the actual customers are that you're shipping to.
So you have to get permission for each sale that you make to each different country?
We do, through the Department of Commerce. So
That's what I thought.
there's still an export process, but it's a lot easier than ITAR.
Now you sell
So
overseas,
dual
but
use
don't do that.
technology.
Well, just to give you guys a glimpse of the nightmare these two are just having right here. Helen sells to the military, and so she's governed by state at a very high level. Jonathan sells not to the military, so he's governed by the Department of Commerce in a slightly lower level, and we're open source and we're not governed at all.
And as BAE, we get it from everybody.
So Matthew, when you hear all this, you work for the victors of the first era of the of the UAV industry, military, aerospace industry, defense contractors. When you hear us upstarts talking about bottoms-up, personal computer, homebrew computer, just the smartphone stuff, does that strike you as opportunity or threat?
I personally, just coming from the background of the upstart, view it as opportunity, and I don't see the big aerospace companies really as kind of the victors of the first wave, if you will. I mean, I think history is being rewritten again. I mean, this has all happened. I mean, if you look back to 1903, an airplane flew, right? What happened when that airplane flew? An entire industry was built around it in the next 25 years. And you have the golden age of aviation from 1920 to 1930 when the CAS was developed and the Defense Department figured out how to use airplanes, et cetera. And if you rewind in UAVs back, let's say 20 years, because they did exist 20 years ago, you had a very similar, very kind of a watershed event, right? Is that you took the pilot, really the only thing that happened is you took the pilot out of the loop because technology enabled you to do that in some way. And as we move forward, also looking back historically, the first adopter, the earliest adopter is the guy with the deepest pockets who has the biggest need. And in that instance, in many respects throughout history in the US, I think dating back to probably the time that we actually became our own country here, quite frankly, was the military. They've invested in everything. Just go down the list of some of the things today that we think are very normal and typical that we use on a daily basis, and they were the early adopter. They had the pockets. They had, somebody mentioned, we've done a great job of going out and getting government funding to develop technology. I raised my hand and plead guilty. We did a great job of that. And we continue to, and the big companies, fortunately or unfortunately for the entrepreneurs, the big companies have an advantage in doing that with the government, with specifically the defense industry as a whole. But that said, they're an early adopter. They're typically not cost or price sensitive, right? Right? I mean, they need it, and they need it now. They want it now. They want it right. They want it robust. They don't want it to fail. I mean, they have all the right mentality and all the right drive, and they're willing to pay for it, and they pay in 30 days. As an entrepreneur, find somebody who does that other than a consumer with a credit card, right? And even then, they take 2% or 3%. But so I think from that standpoint, I think moving forward, I think that paradigm will continue to some extent. I think that it will probably not be in the platform area. The government's is already helping change that paradigm they have the mantra COTS. You guys probably know what that is, commercial off the shelf. So they're already starting to move down that route where it becomes more of a lower cost, procurement card, computer, laptop, smartphone-like purchase. And to the extent that we're able to continue to deliver product in that arena and use the government dollars to fund the early adopter development of the technology, I think everybody stands to benefit. Just go find it and get it. Control the intellectual property, and they'll be willing to pay you well for it.
We have about 5 minutes of panel discussion, and I want to get to controversy. But before, I have to ask Helen. Ask you one question, Helen. What's to stop any of us from putting strings on our drones? Do you have a patent?
Well, not on a
That's
a
a loaded
string.
question, by the
No,
way.
but I mean,
She hasn't filed.
But the power, communications, et cetera. Yeah.
You have a patent on filament.
Yeah, on the microfilament specifically.
Well, they've been
Certain-
using fiber optic tows for weapon systems for years.
So you think
And
we
they
can
don't
beat held
Vietnam.
But they don't do power. It's a communication system where you get the camera signal back.
But you know patent law says not obvious.
What's that?
Oh my, okay.
Let's move on at this point.
We got into the controversy part a little faster than I expected.
I think what I think what you're getting at though is an important point, which is a question that we always ask of companies, which is, what can you do that nobody else can do, and why does that matter? And Helen has built a platform that can do something that many other systems can't do, which is have really long-term duration or persistence. And for certain applications, that could be very valuable. So I think it's really interesting what they've done, and attractive in the sense that that is something that's defensible, where a lot of companies in this space won't have that advantage.
Well, they don't have to carry their fuel source either,
Right.
Yeah.
which is a big logistics issue.
I think more to the point, it's actually quite tricky to do, and maybe not if you want to go, 50 feet or 100 feet, but our customers happen to want to go to 1,000 feet, and 1,000 feet is actually quite high to run a small microfilament. Because of the weight of the microfilament, it weighs 1.5 pounds.
Sure.
And if you go to a lower gauge wire, it'll weigh more.
Right, right. So to finish on sort of the controversial note, drones have a bad rep. It's fair to say. I know you hate the word drone. By the way, what word would you like?
I don't hate the word drone. I've just got used many years for hearing UAVs from the military.
You would say UAV. What would you say, Zack?
Drone.
Both, I guess.
John?
We use both depending on the audience. who
Both
you're
being
talking to.
drone and...
And UAV or UAS, actually.
Yes, true.
A Kleenex is a Kleenex.
Anyway, if you read the headlines, today in the newspapers, drones are associated with killing people and surveillance, probably in rank order of scariness. It is a controversial industry right now. We are in a moment where we are either going to deal with a public backlash on this technology, or we're going to recontextualize the word. Remember, this 'twas ever thus, right? The internet used to be ARPANET, used to be military technology. The computers were designed for things like artillery trajectories and missile paths. The GPS was cruise missile controllers. We have consistently demilitarized technologies and destigmatized technologies, but it takes time. Right now we're in a situation where I think there are 50 locales around the country right now that have anti-drone legislation. Good luck to them. They're a little unclear. Many of them are a little unclear about the jurisdictional paradox, which is to say privacy is a local issue based on community standards and reasonable expectation, whereas the airspace, as we discussed before, is controlled by the FAA, which has no particular mandate for privacy. This is going to be messy. This is going to be super messy. Let's just talk about it. So Helen, you showed bridges as one application, and yet presumably most of the people out there think you're going to be spying on people's homes.
The homeless people under the bridges are going to feel spied upon.
The homeless people under the
And they have a
bridges.
big lobby. No, but seriously, I am as concerned about privacy as anybody else. But I know I'm preaching to the choir here, but privacy goes beyond drones. It shouldn't matter whether you put whether you look across to another apartment building, or you put it in a balloon, or you put it on a manned aircraft, or any other way you can get a camera to places. And you should be looking at what kind of ground sample distance can you put on somebody's property or into their window, and legally, rather than make it about drones. And then, as you mentioned, to have the FAA take on privacy, because their expertise is safety, it really doesn't make sense. But I do believe the FAA would be much closer to opening the airspace today if the privacy issue hadn't come up. But I think it's a little misguided to put it into the drone space, and we should be talking about privacy as an issue in itself.
So how do you think this will play out? I mean, right now the ACLU, for example, is marshaling an army of opponents of drones. How do you
And the
think this-
Electronic Freedom Foundation. I'm usually with them on their topics.
and EFF and my hometown of Berkeley and many others. How do you think this will play out?
I think just like when other privacy issues come up, like having cell cameras in cities or the Google streetcar coming around, it becomes an issue for a while. And then when people get used to the technology and they see their nephew or niece have a drone that they're flying around, I think people kind of get used to it. So you getting a lot of drones out there really will help that.
So you kind of overwhelm the bad narrative with good narrative.
Yeah.
Yeah.
All the good things they could be doing, and then people will make the case to me, well, then drones don't do those things, they're just for surveillance. Well, they don't do them because the airspace isn't open, so we have to, it's kind of a catch-22.
Yeah. Let me skip over you for a moment, Zack, and go to Jonathan. The example you gave of Kenya is an example of a good example. Can you, that would, if enough of those examples came out, would change the narrative. Can you give me some more examples of things you think may change people's perceptions?
Sure, and I think part of it is that it's easy for people to imagine a lot of the negatives. It's the kind of thing that we see in science fiction movies. People can imagine, one of these parrot air drones, but a militarized version of it, looming over their house. But they're not familiar with a lot of the positive aspects and the ways that, for example, we've talked with police departments, and when people hear about police departments getting small drone aircraft, they're thinking, police chase or, spying on my home. But when we've talked with police officers, some of the things that they would want to use it for immediately is, for example, responding to a robbery in the middle of the night at 2 o'clock in the morning, and you show up at the 7-Eleven and the alarm's gone off and you're looking for where the guy went. Well, there are police officers telling us that there's actually a pretty serious fraction of the time where the person's like up on the roof because they can't flee the scene, but they're hiding out. And they have to either wait a long time for a manned helicopter, which is very expensive, and flying those at night and all the time is dangerous. Or they have to call for backup, or someone ends up climbing up on a ladder and sticking their head over the edge of the rooftop. So there's a lot of cases like that where people's lives can be saved. We can create safer situations. We've talked with insurance companies who are interested in doing types of inspections where they're currently done by people, and they're very dangerous inspections. And then probably another one is firefighters. So in areas where there's wildfires and there's so much smoke that you can't really see in a lot of cases where the fire is and where the fire isn't, having these small drones overhead with infrared cameras, for example, make it very easy for firefighters to understand where are the hottest areas of the fire and where are the safe areas for ingress and egress.
Matthew, let me ask you the last answer to this before I take questions from the audience. And I think there'll be an iPad. Maybe there is, in fact, an iPad under my desk, under my chair that has questions. But when you go to a cocktail party, Matthew, and you tell people what you do, and they sort of recoil in horror, how do you explain to them that it's not as scary as they think?
Well, I mean, there's nothing that the airplane does with a visible camera right now that isn't already being done. There's
So in other words, it's scary, but the world was already scarier than you knew?
They're worried about proliferation, right? They're worried about the quantity of them. But the police carry infrared EO and IR cameras today. You go to London, and there is not a square meter of London that is not on a camera on a stick somewhere. You go to, I'm sure Palo Alto here has their own camera systems. I would almost guarantee that the police departments in this area monitor and have aircraft equipped with better cameras, far better cameras than we do today. The Earth is mapped can go on Google Earth, look at it. That's sub-meter resolution imagery of your home. When you look up your address in Google Earth, you can see your dog in the backyard.
So let me
There's
push
nothing
back.
a drone is going to do that the satellite didn't just do.
So this reminds me a lot of, the CEO's son, Scott McNeely, said, you have zero privacy already. Get over it.
Yeah.
That's not the most inspiring response.
It's not. It's the realistic response, though.
Can you give me something better than you've already lost your privacy? Get over it.
I think, as is always the case, the concerns about the negatives, I think, as you said, are always front dead center. I mean, everybody looks at it and goes, this is the reason that we shouldn't have them. I think when some of the usefulness comes out on an individual basis, or for the individuals within the society, if you will, not the least of which, like you pointed out, is poaching or ag research, et cetera, where there's some genuine improvement to our quality of life, right? Because that's what everybody immediately judges, is how much better am I today than yesterday. I think that you'll see the concerns diminish a bit. Until that time, they're going to worry about proliferation, and you have a camera and you want to go look at your neighbor's house and you fly it over the top of it and do it.
I
But
agree.
they do that today.
I agree
That's
that
legal today.
It is, so you can do it today, so there's not really anything to fight.
I think the conversation changes immediately the moment that people have something they consider useful
Tangible,
that
yeah.
someone tries to take away.
Yeah.
I mean, has anybody ever tried to take away an iPad from a 2-year-old?
Yeah.
Yeah. Or an iPhone now.
Okay, I'm going to switch now to the audience questions, which I presume are coming through some magical method, updated live on my iPad or somebody else's iPad. Is that true? Yes. So they're just updating. Okay, brilliant. First question: bad guys. What happens when bad guys get this stuff? Right now,
Define bad.
I'd rather not.
Yeah.
But no, I mean, we're talking about technology by which the United States has had an asymmetrical advantage to date, and we're also talking about technology that's open source, in your pocket, and pretty much out there for anyone to use. So, this was military technology yesterday. It's everybody's technology tomorrow. Talk to me about what. Give me a nightmare scenario. What are bad things that people could do?
Well, in my neck of the woods, in Boston, in Framingham, there was a guy who was going to load one up with explosive and fly it into the White House, and it was human intelligence that kind of stopped it going down. But that's something that's possible
in fairness,
to do.
I think that was, in fact, a radio-controlled airplane which has existed for 40 years. Mm-hmm. So to be a little precise about a drone, you could argue that wasn't a drone. Right? He could have done that 30 years ago.
What's that?
He could have done that 30 years ago.
Right, with more effort on his part and a lot more cost involved. Have to actually build some of it yourself. Now you can buy the components very, very easily.
Okay. All right.
Well, obviously, the first bad that comes to everybody's mind is delivering a small weapon.
A small weapon.
We had a congressman in a Hask hearing that shall remain nameless 10 years ago. Can you put C4 in it? Yeah,
Easily.
you can.
Do you know what else you can put C4 in? A FedEx box.
Yeah, that's what I mean. So yes, you can. You can do it in a Cessna 172 too, as everybody knows. But at the end of the day, that's the first thing that comes to mind. But that is in the hands of the bad guys already.
Yeah.
Period.
I don't have an answer to the question, but I read an article years ago that kind of sparked my imagination in a scary way. There was a clever group of, I believe, Japanese teenagers that were wiring up small cameras to little remote control helicopters.
There you go.
And they were flying them up to scout locations where they were going to steal stuff from. So they'd fly into windows or open windows to try to figure out who had the most valuable stuff in their apartment to kind of scout locations to steal from.
Climb the wall.
Yeah.
Here's another question. Why won't the Chinese dominate the cheap drone market?
They will.
They will. I mean,
Because Chris is going to stop them.
well, no, I mean, I think that the Chinese are worth mentioning right here. The Chinese are awesome in this space. We were designed from the ground up to compete with the Chinese. We built production in Tijuana, which is price parity with Chinese production, and we have open source innovation, which we thought was our only saving grace. But we pretty much, I mean, with all due respect, we ignored the aerospace industry. We said the 21st century is about competing with China. We're designed to compete with China. There's a couple companies, DJI Innovations, Zero UV. They're serving the Chinese military on the engineering side, and they have access to the Foxconn level production on the production side. They're the only competitors we take seriously. How about you?
Well, I do have some experience from my past with Roomba, and we've always felt, it's just around the corner. Any country, with cheaper labor costs could take it on. But we found with it was hard for them. It was easier for them to duplicate. They would kind of not quite get it right. They didn't have the tolerances right, they didn't have all the software right, and it didn't really work as well, so it wasn't what, usually they came on the market and then went off immediately because people wouldn't buy them.
And you think that's still the case? Because, I mean, I've been amazingly impressed by the Chinese drone industry. I think they're basically, anybody who thinks the Chinese are copying at this stage are not paying attention.
They already have that market in a sense, because I'd say probably 90% of the ready-to-fly aircraft that you can buy on your hobby, on Tower Hobbies, are manufactured there.
Exactly.
And you can take his autopilot and put it in a ready-to-fly airplane and put an engine on it and make it a drone.
Jonathan, what's your China strategy?
I think that, and maybe at a bit higher place in the market than kind of the ubiquitous, hobby solution. I think a lot of the value at the end of the day is really in the software, and so Is the hardware going to be completely commoditized and you have to match the prices of Chinese manufacturing? Yeah, maybe, but I think there's going to be a lot of continual innovation in the software layer that does things like multiple vehicle control, mesh networking, continually increasing reliability to deal with failures in real time, to recover the aircraft in safe ways. And so, I think that is where a lot of the value is going to be long term, and I think it's going to be continually developed and continually improved. And it's hard to kind of copy or innovate as quickly.
Zack, Jonathan seems to suggest that the Chinese won't do software as well as we can. Do you agree?
I don't know. I mean, I think everyone's had experience with a product made in China that might not match its better, higher.
You mean
higher.
The iPhone?
Sure. Well, keep in mind the iPhone's made in China but not designed in China, and I think that's a big difference. But when you think about building businesses around this space, I don't know if it makes sense to compete with China. Maybe you want to instead take advantage of that competitive dynamic and build a business that's agnostic to whatever platform or system you're using to take advantage of these increasingly declining costs. So go after an application where you don't care if a drone is being built by 3D Robotics or the Chinese company that's copying your stuff, and maybe that's an opportunity for people to think about. I mean, the other angle is to invest in something that they can't copy, which is just so new and state of the art that they don't know how to do. In full disclosure, we have an investment in a metamaterial satellite antenna company. I mean, this is a huge breakthrough in material science, lets you bend light in ways that weren't possible before, and you can get a beam steering antenna that doesn't require any mechanical parts and is the size of a piece of paper and runs on milliwatts of power. And for persistent, high bandwidth, low cost communications, that's revolutionary. And the Chinese can't copy that because they don't know how it works, and they won't for a while. And so that's one example of a way you can try to play it.
Wait, can I ask you a question?
Yeah.
Why didn't you set up manufacturing in China rather than Tijuana?
We did. And then we moved it back.
Did you? Why though?
Because it was 9 months of delay. All of our cash goes into the supply chain. We couldn't control the quality. Turns out that we can all buy robots for the same price.
So there's the competitive advantages of today.
We went from I think we're 10% more expensive and 1,000% faster.
Okay.
I think the 21st century supply chains are going to be built around speed, not money. Last question, which I think is going to probably take us to the end, which is really about sort of what's next. What are the unsolved problems? And the question is phrased here in particular regards to sense and avoid. So just to give everybody a kind of a, here's the one thing drones can't do. The FAA is a good lens on this problem. The FAA is built around largely protecting the safety of the airspace and travel in the airspace. And this is built around two fundamental principles. One is sense and avoid, and the other is pilot in command. Sense and avoid means, there's somebody in an airplane looking around to see if there's anything else on in a collision course, and then the second thing is that they can do something about it. These are unmanned aerial vehicles. There is no one in the cockpit. The reason the FAA says that we have to fly within visual line of sight is that someone on the ground has to substitute for that person in the cockpit. You have to look around and see, because the air traffic control cannot ensure that no collisions happen. So this problem of sort of sense and avoid, how do these drones avoid manned aircraft, avoid other unmanned aircraft, avoid birds and trees and telephone lines, et cetera, is a serious AI computational sensing challenge. And why don't I just go down the line and say what's the future of sense and avoid?
Well, I don't see how it can be that hard a problem. You put a transmitter in each of the vehicles that are flying, and you use something like Sky Radar to have every other vehicle know where they are, and then you have a backup of sensing,
Right.
vision or some kind of active sensing around it in the ground robot field, which I've been in for many years.
Yeah.
We have robots running around in buildings, and I think we can take a lot of that stuff into the air vehicle space. I do want to work on more and better sensors, and the technologies are just proliferating in that area based on exactly what you said, and getting more of those onto the robots is where I'd like to go.
So you've described transponders on the vehicle to vehicle, and then sort of ground sensors. But I mean, birds don't carry transponders, trees don't carry transponders, small children
I don't
on
think
the
they
ground.
avoid every bird when you're flying.
Well, a pilot is able to avoid trees, able to avoid telephone lines,
Well, they're
able to
usually
avoid
not
bright lights.
in the way. You go to a runway that usually doesn't have that stuff around.
Okay, Zach, what's your answer? When you look at sense and avoid being the biggest
I think this
opportunity.
space is wide open for disruptions in computer vision. It's a space that has seen limited real-world applications, but I think its shining moment is coming. I mean, we're seeing processing and compute power just get cheaper and better. I mean, the GPUs that are available today running on mobile devices are amazing. And when you leverage that with better sensors, sensor fusion, so not only relying on vision, but whether it's ultrasound or something else, and then you couple that into a package, and then 3D sensing too. I mean, when you talk about what's happening with PrimeSense, which provides for the Kinect, and all of those mobile phone companies that now want to implement 3D sensing into their devices, I think within the next 3 years, we are going to have much more sophisticated 3D sensors that, coupled with really clever algorithms and processing, are going to build machines not just in the air, but on land and in the ocean and all over the place that can interact with their physical environments in much more intuitive ways. I mean, you look at how easy it is for us, or even a very basic animal, to do sense and avoid, and how hard that is for robots today. It's embarrassing. I mean, I was just in Half Moon Bay the other day, and I was watching these birds just elegantly fly on these cliffs and hover, and go for hours on the power of a sand crab and be able to chase a breadcrumb in the sky, and that it's like this basic. We're so far away from that. I mean, which gives me hope and makes me believe there is a huge amount of opportunity here. So I think we're going to see a lot of innovation in computer vision, particularly applied to this space of robotics broadly, and it's an area we're actively looking at.
Well, that's the quote of the day. Go birds flying for hours on the power of a sand crab. Nicely done. Jonathan, sense and avoid. What's the future?
Yeah, so I'm actually a commercial multi-engine rated pilot, so I've done a fair amount of flying and avoiding other aircraft. And I'll tell you that birds are actually pretty good at avoiding you most of the time.
You don't move out of the way of them.
Right. The see and avoid problem, you should consider both sides of it. So it's not just up to the UAV to avoid a manned aircraft, but you also need to give manned pilots the tools to be able to see and avoid these very, very small aircraft, which are almost invisible to the naked eye. And that's where transponders, I think, are going to absolutely be a very important part of the solution, especially for any UAVs flying above, whatever the FAA decides that altitude is going to be, probably 400 feet, maybe 1,200. So transponders on a lot of the UAVs if they're flying above these altitudes, but then also, the algorithms and probably a fusion of multiple sources of information, communication between vehicles so that they know each other's GPS coordinates, but then also vision as well.
Matthew, you have the privilege of the final word.
Yeah,
close us out with BAE's perspective on the
well,
future of aerospace
I
engine.
think that I'm a pilot as well, commercial pilot as well, but I want to a little distinction real quick is that the current aerospace paradigm is not defined by sense and avoid, it's defined by active control. And I can fly into clouds as a commercial pilot, instrument-rated pilot on the way home tomorrow. And the critical thing in that instance is I have a series of protocols and procedures if I can't remain in contact with the control authority at that moment to do certain things under those certain circumstances. And when they call me and ask me and I say IMC, which means instrument meteorological conditions, it means my sensors are off. I can't see. I'm under your control and in your hands. And then they will tell you to do certain things. Vector, change course, other aircraft in flight. And the FAA, what they've done is they've stratified the airspace, right? So you have A to G airspace. In G, you can do largely anything you want as long as you're not putting somebody at risk, flying close to dwellings and people, et cetera, et cetera. And I think they're going to follow that paradigm in answer to your question, I think they're going to follow that paradigm. Now that said, from a sense and avoid standpoint, I think the future of aviation is sense and avoid. And I'll throw some acronyms out there: LIDAR, SAR, synthetic aperture radar, radar. I mean, it wasn't, in the last 10 years, I've personally seen synthetic aperture radar that were military devices that were hundreds, if not thousands of pounds in a developmental size that I've flown on our little Silver Fox airplane, which weighs 32 pounds. So from that standpoint, that's an enabling or a disruptive technology that truly allows sensing in any meteorological condition. Rain, sleet, snow, cloud, dead of night, et cetera. And as soon as those sensor ability, I think we have the software capability and the processing capability to actually do something with it. As soon as the sensors are sufficiently packaged and small that we can actually have a hemispherical 360-degree view of the aircraft in its flight to a certain range, a reasonable range, we'll be able to process it and have the aircraft do what it's supposed to do to stay out of the way.
So safer than a pilot. It never blinks. It never sleeps. It's got 360.
But they'll put it on manned aircraft too at that point.
Yeah.
There'd be no reason not to. It makes the pilot better.
So drones make the airspace safer.
Yeah, yeah.
On that positive note, please join me in thanking
Yeah.